Good afternoon, my name is Christopher Shaw, and today I'm going to do a presentation on industrial chemistry for the subject code OSHY2400052. For this assignment, presentation on industrial chemical for safe and sustainable industry for Wisma Merdeka shopping mall. My student code is SCSWK2400052 and my lecturer is Puan Rosaline binti Haji Basran. So here are the simple background for the Wisma Merdeka. So the title for my presentation is Industrial Chemical for Safe and Sustainable Industry for Wisma Merdeka Shopping Mall, whereby I have the subtitle for Industrial Chemistry for Safe and Sustainable Industry, focusing on the cooling tower water treatment at Wisma Merdeka Shopping Mall. The objectives of this presentation is to balancing a public safety, operational efficiency, and environment care. So the critical infrastructure for Wisma Merdeka here is because of we are operating a massive centralizations of this chill water system, or we call it air conditioner. It's a commercial air conditioner to maintain a thermal comfort for thousands of daily visitors for Wisma Merdeka. Wisma Merdeka, or a generic diagram for commercial building, this cooling system infrastructure. Here are some illustration. Here we can see the cooling tower that are situated outside the building, and then of course the cooling tower, when it's operate, this cooling tower will send in this water into the chiller, and the chiller will produce cold water to the chill water, we call it chill water, to the air handling unit, and this air handling unit will actually dispose of through the air, cold air, and then of course this water will return back to the air handling unit, as well as go back to the cooling tower, and it will rotate this way. Yeah, it will rotate this way. So here are the another example that you can see how the cooling tower works. Yeah, here you can see a giant cooling tower. This one is belongs to another shopping mall or another big complex in Sabah, which is belongs to Imago shopping mall. Yeah, because it's a very huge cooling tower. So in Wisma Merdeka, because our building is already 40 years, so this is the early cooling tower that we are still using right now. So the introduction, the relevance of industrial chemistry. Why is it that industrial chemistry matters in shopping mall? Because water is the main medium for cooling towers used to open evaporate water loops to reject heats from the building. So the chemical challenges that the cooling tower is facing is a warm stagnant water is the breeding ground for biological pathogens, mineral scaling, and metal corrosions. So the solution here is by providing a precise application of industrial biocides, inhibitors, and pH adjuster is to require daily to ensure that public health and system longevity. So it operates a massive centralization chill water system to manage thermal comfort for 1,000 visitors for Wisma Merdeka shopping mall. So the application, how it works is that the cooling tower treatment process. The process continue automated dosing and monitor of chemical agents into the cooling tower basin to control water quality cycles of concentrations. Yeah. So the reactions involve the oxidizing biocides hydrolyzed in water to produce hypochlorous acid, which penetrate bacterial cells or to destroy pathogens, and phosphonate absorbs into minerals microcrystal to prevent a scaling or crystallization. So another what I call that example of this another picture. Okay, and here you can see our maintenance staff doing these what they call that, the dosing, the chemical dosing to the cooling tower every week, and from there we are getting the readings. So after that before and after. Okay, before the dosing, we do the testing of the water, the quality of the water, and get the readings. And then to ensure that the water quality is followed based on the requirement. Here you can see every month we are doing the monthly cleaning on the cooling tower basin. We release all the dirty water together, come with the chemicals, and then here we can see use the jet spray to spray off all the algae, and at the basin you can see some greenish things, that is the algae forming. And here you can see the before and after. Before, there is the algae that grow here, then after the cleaning, because some of the algae are still going to stick at the floor of the basin. So apart from that, we are also do a deep cleaning in the HU, the cooling coil. So we, of course, on every month we are doing the cleaning for the filter, but on this 6 months or yearly basis based on the budget, so we are doing the what they call that deep cleaning over the what do you call that, the cooling coil. So if the cooling coil is well maintained, then the, the cooling coil can produce cold air, right? So here you can see we are doing deep cleaning by using a vacuum pump, and it circle inside the cooling coil, and it cleans all the dirts and inside the cooling coil, right? And here you can see after the cleaning circle, so we throw away all the dirty waters and then put in the clean water until the cooling coil is fully clean, until the water is clear. Okay, using some pump. Okay, the chemical class that we are using here is the oxidizing biocide, non-oxidative biocide, scale and corrosion exacerbator, and pH adjuster. Okay, the compound example here are the compound example that we are using. What do you call that? Technical words. And the purpose here is to kill algae, to alternate with chlorines, to prevent bacterial immunity, prevent calcium carbonate and build up the pipe rusting, and also the balancing of the pH. Okay, the safety, occupational safety and health issue for and hazard at risk workers, right? Safety and health risk chemical on this chemical hazard is number one is the corrosive. The concentrated sodium hypochlorite and scale is inhibitor cause a severe chemical burns to skin and eyes. So the toxic vapors, inhalations of chlorine gas or chemical mist during the mix handling and can cause respiratory distress. Therefore, each of them are compulsory to use a mask. Yeah. And then a biological hazard exposed to untreated cooling water drift aerosol infected with this what you call Legionella pneumophila, causing a severe of pneumonia. And who are the at risk here is our maintenance technician, the engineers and chemical delivery personnel during the chemical replenishment and manual basin cleaning, right? So the control measures here, what we are doing is we through engineering controls install automated close-up loop chemical dosing pump directly from the chemical drums to minimize the manual pouring. High efficiency drip implemented on cooling tower to reduce aerosol release. And then another way of control is administrative control, whereby we place the mandatory SDS station at the plant room, and regular water sampling protocol to restrict the strict standard operation procedure and strict standard of the SOP, and PPE is mandatory to contain the chemicals, flash, goggle, heavy duty inhaler gloves, okay, face shield and chemical resistant apron during the handling. We also face some environment issue. Environment impacts and mitigations. The issue here is blowdown water discharge to prevent mineral overload. A portion of the chemical treated water blowdown must be periodically discharged. So we discharge it batch by batch. We don't release it at one go, right? How the impacts occurs is discharging water in high residual chlorine with toxic and non-oxidizable bioxide and heavy dissolved solid directly into the municipal storm drain harm the aquatic life in a local waterways. Actually, this one can kill the fishes that's in the drain. And the control strategy is dechlorination. Utilizing sodium is to neutralize the residual chlorine before discharge. And then retention equalization tanks holding blowdown water to cold and allow bioxide to neutral degrades before release into the sewage system. Okay, so the sustainability improvement strategy 1 and 2 that we have proposed. Okay, so implementation of green chemistry, a biodegradable inhibitors. Okay, transition from persisting chemical to family the green scale inhibitor such as polyaspartic acid, or they call it PASA. Water mineralization via circles of concentration (COC) optimization using advanced real-time conductivity control to safely increase from 3 to 6 that drastically reduce both freshwater consumption and wastewater blown down volume. So another scientific improvement strategy for 3 and 4 is advanced clean productions and system, physical and non-chemical water treatment alternative, investigate the UV of distribution of electrical system to reduce reliance and systematic chemical biology up to 70%, and also by adopting an environment management system like plant operator with ISO. So this one is a very high standard, setting measurement key KPIs for chemical usage, water footprint, and energy efficiency is essential. Okay, so here are the reference for the what they call that my presentation just now. Sorry, I missed the previous slide, so I cannot go back again, lecturer. So I missed the previous slide too fast. Okay, so here I have the additional reports to substances for this presentation. The hazardous substance report on the TB3002 for Wisma Merdeka shopping mall. So this is the chemical that we are using for the cooling tower. Okay, so here are some reference that related to this our cooling tower. The appendix for this presentation here is the SDS extract for TB300, sample labeling with hazard particulate, and photo of PPEs of storage and cabinet. So here are the SDS safety data sheet for this TB3002. Yes, yes, and also the sampling whereby they have a warning label at the chemical. And last but not least is a photo of PPEs and storage cabinet. Okay. Thank you, and here ends my assignment. Thank you very much.